Good morning students. Today in this video we'll see a problem how to solve the given differential equation. So here you can see the given problem is d square plus 6d plus 8 into y equal to e power 4x. So the solution of the given differential equation is y is equal to complementary function plus particular integral. We know this very well, right? So now first I'll find the complementary function. So underline the concept complementary function. So to find the complementary function, we'll assume that the given equation is equal to 0. So let us assume d square plus 6d plus 8 into y is equal to 0. So after writing this, we need to find the auxiliary equation of the given problem. The auxiliary equation of the given problem is, so in place of d, we need to write the value of m. We need to take only the terms of d. D alone we need to take. We should not take y to write the auxiliary equation. We need to write only the value, only the terms of d. And in place of d, we need to replace it as m. So if we replace it as m, we get this equation to be m square plus 6m plus 8 equal to 0. Now as you can see, this is a quadratic equation. Now we need to find the roots of the quadratic equation. As you can see here, the coefficient of m square is 1. So 1 into 8 will give me 8. So I need to take two values such that the multiplication should give me 8 and the addition should give me the value 6. So I'll take the values 2 and 4 here now. I'll just assume 2 and 4. As you can see, if I multiply 2 into 4 is 8 and if I add 2 plus 4 is 6. So as you can see, 2 and 4 are the correct terms here. So I'll replace 2 and 4. I'll rewrite this equation to be m plus 2 into m plus 4 equal to 0, because 2 and 4 are in positive signs. So I have written m plus 2 into m plus 4 equal to 0. Therefore the value of m will be minus 2 comma minus 4. Here you can see that the roots are they are real and unequal. The roots are real and unequal. Therefore, the complementary function is y is equal to a e power minus 2x plus b e power minus 4x. So this is my complementary function. So I got the value of the complementary function now. Next I am going to find the value of the particular integral. So I'll write the heading here, particular integral. So to find the value of particular integral, I'll write particular integral is equal to 1 divided by, I need to write the terms of d alone. So d alone terms are d square plus 6d plus 8. So write it in the denominator, d square plus 6d plus 8 into, here in the RHS it is given e power minus 4x. So write the RHS value here, e power minus 4x. So this is equal to 1 divided by, so as you can see that this comes under type 1. Type 1 is of the form e power ax. So if we have type 1 form, we'll replace d equal to a. Wherever we have d, we will replace it by a. As you can see here, the value of a is minus 1. So I'm going to replace a equal to minus 4. Sorry, the value of a is minus 4 here. So I'm going to replace d equal to, wherever we have d, I'll replace it as minus 4. So I'm going to replace now. So d square, it is given, d value is minus 4. So d square will be minus 4 the whole square plus 6 times d value is minus 4 plus 8 into e power minus 4x. So this is equal to 1 divided by minus 4 the whole square is nothing but 16 minus 6 into 4. 6 4s are 24 plus 8 into e power minus 4x. As you can see here, 16 minus 24 is minus 8. Minus 8 plus 8 is 0. So this is 1 divided by 0 e power minus 4x. So as you can see here, we have in the denominator we get the value 0. We are not getting any value here. So you can see here the problem it ends with the term 0 in the denominator. So if we have a problem like this, then we will apply the case of failure for this type of problem. So now I am going to apply case of failure. Applying case of failure. So what is my case of failure? So what I am going to do is, the particular integral will be written as pi is equal to, as you can see, this is the beginning of the particular integral, right? So for applying the case of failure, the term will becomes particular integral pi equal to, in the numerator we will put x, and in the denominator you need to differentiate. So the denominator should be differentiated and the numerator should be multiplied by x. So in the numerator I have multiplied by x, and in the denominator I am going to differentiate. So differentiation of d square is 2d. Differentiation of 6d is plus 6. So 2d plus 6 into e power minus 4x. So as you can see here, again this comes under type 1. Here we have, in the denominator we have d terms, right? So we'll replace d equal to minus 4 now. So if we replace d equal to minus 4, the term will become x divided by 2 into minus 4 plus 6 into e power minus 4x. So this is equal to x divided by 2 into minus 4 is minus 8. Minus 8 plus 6 e power minus 4x. So this is x divided by minus 8 plus 6 is minus 2 e power minus 4x. Therefore, the particular integral can be written as minus x e power minus 4x divided by 2. So this is my particular integral value. Hence, the solution is, we know the solution is y is equal to cf, that is complementary function plus particular integral, that is y is equal to my cf value, as you have seen here. My cf value is a power minus 2x plus b e power minus 4x. So I'll write it, a e power minus 2x plus b e power minus 4x plus the particular integral which we got just now. So it is given in the negative sign, so I'll put minus here. So minus x e power minus 4x divided by 2. So this is my final solution of the given problem. So if in the denominator, if we get, carefully listen, if in the denominator if we get the value 0, then we'll apply the case of failure. So first time we are applying the case of failure here. So in the particular integral, you need to multiply it by x and the denominator should be differentiated. And we need to substitute the value if we get some value. So this is my final particular integral. If after applying the case of failure also, if the denominator becomes 0, again what we'll do in this particular integral equation, we'll multiply x in the numerator again. So x into x will become x square and the denominator should be differentiated. If we differentiate this term will become 2. So 2, if we differentiate 2d, we'll get 2, right? So in the denominator we get 2, okay, and after we need to substitute it, okay. So be careful in this problem. Applying case of failure is a very, very important sum which comes every time in the semester examination. So kindly go through it. Thank you so much.